Okay, well, thanks everyone for joining today on a blustery evening. So I appreciate you making the trip in. Today's speakers are myself and David Mayberry. We're going to be talking about energy efficiency, energy audits in the residential environment. So things that you can do and consider at your home to have impact on reducing your energy and carbon profiles, reducing utility costs as an example. So we are volunteering as part of the Smart Energy Oxford group here in Oxford County. Smart Energy Oxford has a goal of 100% renewable energy for the entire community. So the entire community encompasses everything in the entire county, including buildings, vehicles, agricultural equipment, you name it, waste. In my professional life, I work at an architecture and engineering firm called Walter-Fedy, and I manage the energy and carbon group there. David, did you want to just quickly introduce yourself?
No, I'll go later.
All right, I'll do that later. Okay. So I just mentioned Smart Energy Oxford. We'll get into why I do energy audits, what is an energy audit, what does the process look like, what are some incentives that are available. Also talk a little bit about rate structure, and there's some opportunities right now from that side, and some next steps and who to contact. So why do energy and carbon auditing to start? Energy and carbon auditing will give you a good baseline and benchmarking of understanding of where to start with your home, as an example. We all understand the importance of climate change, and we're seeing the impacts of that on a regular basis. A number of years ago, we as a country of Canada committed to the Paris Climate Agreement, looking to maintain the global temperature rise under 1.5 degrees. So anything an individual can do supports that whole initiative. What are some benefits and co-benefits of auditing? You can see lower operating costs, so getting your electricity, natural gas, other fossil fuel bills lower. You can have a more comfortable environment potentially, and there's a good sense of pride and education component that you can support with discussions with your neighbors or otherwise. As I mentioned, we have a significant amount of work to do to achieve our community-wide goal of 100% renewable energy. This is an infographic where it looks at the baseline of 2015, kind of cascading all the way towards 2050. The main thing here is we need to decrease the amount of building heat and fossil fuel associated transportation that we're using to achieve potential goals around decarbonization and renewable energy development. We'll talk a little bit about kind of the priorities in a minute, but I just wanted to mention the kind of primary sources of carbon within a typical environment. So there's 3 scopes. So there's scopes 1, 2, and 3. Scope 1 is direct emissions. So an example of direct emissions is something like burning natural gas to heat your home, or propane, or home heating oil. When you're directly consuming a fossil fuel at a facility or at your home, that's a scope 1 emission. So the emissions are actually happening directly at your home or measurement boundary there. Scope 2 is something called indirect emissions. So the primary example is consumption of electricity. So if you're consuming a kilowatt hour of electricity to run a projector or turn your lights on or turn your oven on, that is the source generation energy is kind of typically a primary function of what's happening in the grid in the province that you live in. So consuming a kilowatt hour of electricity in Oxford County is very different than consuming a kilowatt hour of electricity in Calgary or Halifax or otherwise. That's because we all have different forms of generation. So in Ontario, we're largely low to no carbon, as we have significant nuclear power plants. Nuclear energy is not renewable. but it's no carbon. So there's some benefits there. In other provinces in Canada, there's still things like coal being burned at power plants and large natural gas power plants as well. Other sources of low or no carbon generation at scale are things like hydroelectric, which is very significant in Quebec, also in Ontario and BC in particular, and then things like solar PV, wind energy, or other forms. So in Ontario, generally, one of the main strategies is to electrify as much as possible because our grid in Ontario is generally fairly low on carbon. So that's kind of scope 2 is when you consume like a kilowatt of electricity, but the source of the generation is somewhere upstream. The final item here is scope 3. Scope 3 is kind of the catch-all. Things like driving a vehicle. So the emissions associated with you driving a vehicle would be part of scope 3. Also could include like supply chain, buying products, materials, and all of the upstream emissions associated with that. So scope 3 is kind of the most difficult form of emissions to kind of put your arms around and fully understand. But the vehicles are something which can be understood fairly well. But data is not the greatest there. In terms of kind of general strategy, the most important approach is conservation first. So whatever you can do to use less energy first is best value. So that can be things like retrofitting of your building envelope, changing the set point on your thermostat depending on the occupancy of your home or otherwise at certain times of day. Having a little bit of automation on your lighting potentially. So anything you can do to conserve energy first is most important. Secondarily, you get into things like fuel transition. So if your furnace at home fueled by natural gas or propane is at its end of life, you consider, replacing it not with a like-for-like system, but perhaps a heat pump system or a combined heat pump fossil fuel system, so that you can strategically use energy most appropriately. Then the last line is things like renewable energy. So if you have a south-facing roof exposure, you might consider renewable energy like solar PV. Or if it's feasible for you and you don't have access to something like natural gas, maybe geothermal to provide energy for your heat pump is something as well. So we'll talk about that a little bit more. Okay, let's get into energy audits. So what is an energy audit? So you're first benchmarking your performance. So you're looking at your historical utility data to understand how your building is performing. So you'll get an appreciation of where energy is flowing, how you're using it, how it compares to a typical home. You may be able to note that you're performing better than others, or maybe you're using much more energy than you even knew. Next step is to identify some opportunities or energy conservation measures. So what's a list of things that can be identified that you could consider in the short, mid, and long term, all with varying levels of cost, of course. Final three items here are to evaluate those measures. So what are the costs? How much energy, how much carbon is that going to save you? What's a payback on that line item? And then a blower door test as well. So blower door test is something which is typically required to comply with certain programs where you're evaluating how leaky your building is. And then there's energy conservation measures which would be applicable to address any leakage in your building. And then you're summarizing that with recommendations at the end and hopefully creating a plan that could last from 1 year to all the way to 15 to 20 years. So, and it's all kind of with respect to where you're at with your home, what your plans are with that building or whatnot. This one I touched on earlier, talking about the priorities around reducing, so I'll keep moving there. Some typical measures that we might look at are listed here. So building envelope measures, so you can consider upgrades of insulation on your walls and roofs. If you're doing something like a renovation in one of those spaces, that's a great time to include one of these measures in particular. If you have to re-roof your home or whatever at a certain time, that's a great time to look at kind of the whole roofing assembly as well, beyond just replacing shingles. Windows, if you might have aged windows that have been there for many years that you'd like to replace. This is all opportunities that we look at as part of the energy audit. General awareness is very important, so making sure that the people that occupy the space have education on the impacts of their decisions as it relates to energy and carbon. So making sure that thinking about length of showers, lights being on, set points and control items, considering shifting different, dishwashing as an example to a different time of day. Many dishwashers have delays that you can put on them, so you can have reduced rates. So there's many opportunities with general awareness. And then the next few items kind of align with our discussions earlier with lighting upgrades, low energy and carbon systems, and renewables. So in terms of what the process looks like, first step is to contact an energy advisor to arrange an audit. We have links available of reputable organizations that complete these through NRCan, which is National Resources Canada. So that's your first step. Contact them. They'll arrange to come to your home or otherwise to complete the initial assessment and a blower door test. This gives them the opportunity to see your home, understand where the opportunities may be, and complete that blower door test. After which they'll write a report and provide that report to you as documentation that this has been looked at. Then you're working through a series of implementations of those energy conservation measures. So that can happen in the short term as well as long term. We'll talk a little bit about incentive programs. There's one which recently closed, but I assume there'll be something to follow that in the future. So the goal here is to make sure we have a comprehensive list that can be implemented to harness incentives, but also be education for the long term as well. After you've implemented some of these items, the auditor can return and perform a post-audit assessment or report. So that would be to verify that the intent of the measures that were evaluated have been completed and executed on, and hoping that the performance targets that were recommended have been achieved as well. And then whether or not there's incentive available is an important aspect of this too. So this is a screen capture of the energy audit that was completed at my house in Woodstock. So this is just one of the pages where some information is provided. So on the far right, you can see that there's information with respect to where energy is being consumed for the home. And that's kind of distributed between space heating, space cooling, water heating, ventilation, lights and appliances, and other electricity. So depending on kind of your weighted breakdown between those areas, that will impact the value of implementing certain measures as well. There's also a number of metrics over here on the left with respect to energy and energy intensities of the building, which may or may not be kind of numbers which make sense to people. But the key thing here is here's where energy is being used as a start, and then identifying some opportunities. So this is kind of all the key inputs in particular that they've put into their modeling. So everything from the thermal performance of those walls, roofs, window assemblies, through to the heating and cooling devices, as well as water heating devices at the home. So it documents what the inputs were. And now I'm starting to get into some recommendations on the measures. So this is the energy and conservation measures I mentioned. This is one item where it says, did you know space heating accounts for 56% of the estimated annual energy use of your home? So the recommendation here was to replace the existing natural gas furnace with a air source heat pump system. So my furnace was from 1994. So it was in the order of magnitude of 30 years old. So I was kind of looking at it as a bit of a risk, as something that could fail at any time. So I kind of proactively looked into this program, had the audit done, and replaced my existing furnace with a new hybrid heat pump furnace system. So this system can both operate as a heat pump using electricity or natural gas for heating. So the way I've defined its operation is I'm running in heat pump mode, so using electricity until I reach around minus 10 degrees Celsius. And then once the temperature is below that, I operate natural gas. That's because the efficiencies of heat pumps can tail off as it gets colder out. And this also provided flexibility for operating in different arrangements for us. So this is the indoor unit. So it looks exactly the same as most furnaces that are in homes. So this is the outdoor unit for the heat pump. So it looks very similar to condensing unit that you would have for air conditioning of a home. It sometimes has to operate through a defrost cycle. So probably the water beneath is when it was running through one of those cycles recently. So anywho, yeah, it doesn't look any more invasive. Works perfectly with your existing ductwork if you have ductwork in your home, and is a fairly non-invasive solution, which allowed me in particular to lower my carbon impact and shift some of my energy usage over to electricity from natural gas. Other opportunities are with insulation. So insulating the attic was a good item identified here. My home was built in the 50s, so there's been a little bit of insulation over the years, but it has deteriorated over time. So I put new insulation in. Air sealing is something that's identified here. So for older homes or buildings, they're typically quite leaky. So there are definitely many opportunities for low-cost solutions to make sure your building is less leaky. When it's minus 30 out or plus 30 out, if you've heated or cooled your house, you want to make sure that energy stays in your building and you're not just heating or cooling the outside air. So the more tight your building is, the better. This kind of aligns with passive house concepts in particular. So things like weather stripping, caulking. There's also a technology called like aero barrier, where you can actually spray this material in the space and pressurize the space, and then it fills those gaps and then hardens and seals. Not a great thing to do when you have a fully finished space, because it leaves particulate in the space. But if you're ever doing a renovation, it's a really great thing to do before you finish off into finishings for spaces. Yeah, so this is the next one around installation of foundation walls. So a lot of people have uninsulated or unfinished basements. So this is a really great opportunity to create comfortable spaces in basements. There's a lot of energy actually lost through your basements and foundation walls. I had very old. My basement finishing was very minimal. The old owners had dogs, and there was some stains in the carpet and whatnot. So I tore out the existing finishing, and then I studded new walls. I left a gap, a full gap between the new studded walls and the concrete block wall. So there's about 2 inches of continuous insulation, as well as insulation between the studs there. So that was a spray foam insulation that I completed through the Great Northern. Actually did the install there, but I did that myself for the studding of the walls. So right now that space is all finished, and it's very comfortable basement after completing this upgrade to insulation. So certainly, you have to look at the practicalities with respect to where you're at with finishings in your spaces. But if you're ever considering a renovation, it's kind of the time to really kind of consider these types of things. This is just a screen capture of Enercan, their website, where they have links to eligible and recommended energy advisors. So you can put in a location like the southwestern region and postal code where you live, and they'll provide the recommended energy auditors that would be willing to support you in this journey. This conversation is interesting in terms of its time. Earlier this month, the government of Canada announced that they were putting the Greener Homes program on hold. So it's fully prescribed. Greener Homes provided a fairly substantial incentive for things like insulation, installing heat pumps, supported through Enbridge, and provided a lot of dollars for these initiatives in particular. So that's on hold for now, but hopefully there's an announcement of a new program in the coming time. Nonetheless, there's great value to working through auditing and implementing measures regardless of whether or not there's direct funding available. But you may consider kind of holding off on some of the major capital costs. So if you're going to do, replace your furnace, and that's quite expensive, install solar panels, things like that, where it costs quite a bit, you might wait to see if a new program is announced. But having an audit done, doing some of the air sealing measures, insulation, are kind of lower on the capital cost side and can provide you a lot of value in the meantime. The last item here is unique. It's something fairly new. It's called ultra low overnight rates in particular. So there's an opportunity right now. So a majority of people have opted into time of use rates. So those time of use rates are typically off, mid, and on peak. So your on peaks are, more typically kind of early in the morning on weekdays and in the evenings on weekdays. So that kind of 4 to 7 p.m. on weekdays is when you pay the most per kilowatt hour of electricity. Early in the morning on those weekdays is also when you pay the most. So paying up to 18.2 cents per kilowatt hour. There's a new program called Ultra Low Overnight Rates, where if you opt into that program, you are eligible for a very low electricity rate overnight. So from 11 p.m. to 7 a.m., the cost of electricity is only 2.8 cents per kilowatt hour, where your best current rate is the off-peak rate on the weekends, which is 8.7 cents. So it's significantly less than your best rate right now. The key thing there is not using energy during those peak on rate period. So it goes all the way up to 28.6 cents per kilowatt hour. So it's 10 times more expensive during those peak weekday evenings. So where the opportunity lies here is if you have something like an electric vehicle, if you're charging that, always doing it between 11 p.m. and 7 a.m. If you do dishwashing or laundry, setting those on delays so they don't start till after 11. We all understand that kind of the core cooking time for doing dinner is that 4 to 9 p.m. So that's something to be most considerate of. But if you're willing to make a slight change in lifestyle approach, you can save a lot of money by opting into this program. So that's kind of the end of my spiel, and I will. This is just a screenshot of that same thing. I'll hand it over to David to chat about his experience in a rural home compared to urban.
Very rural. Yep.
Perfect.
Thanks, Patrick. As Patrick said, I'm David Mayberry, Mayor of Southwest Oxford, farmer, retired, and always been interested in energy from two aspects. One is from the environmental, climate change and all that sort of stuff. The other is being a farmer, I'm cheap, and therefore I try to save money whenever I can. So I thought I'd just share my personal, or at least our family's personal experience, my wife and I experience over the last few years. We moved into the house we live in now in 2008, in March of 2008. It was built in the 70s. Pretty decent home. The day we moved in today. We woke up the next morning and we knew there was something the matter because I had a headache, she had a sore throat, and my brother-in-law happened to be there helping us move, and he said he could smell oil in the house. The two people that had lived in the house before us had both died of lung problems. And so immediately contacted the furnace guy. He came out and said, oh, you have a crack in your heat exchanger. And so within 72 hours of having moved into this house, we had a new furnace, a new oil furnace, which in rural areas where gas isn't available, it's not unusual to have an oil furnace. So one of the advantages we had was that we knew that we were probably going to be there for at least the next 20 years. At that age and stage in our life, we figured, we'll probably be here for 20 years. So we didn't mind investing in the long term. And if you do that, then you can look at, what's your rate of return, and not just over a year or two, but over a longer period. And that's what we really want to do. So we wanted to reduce our costs, and we also wanted to reduce our carbon footprint. So we did something else. We started measuring every bit of energy that we bought. And so to Patrick's line about scope 1, 2, and 3, this is scope 1. So all the oil we bought for the furnace, all the gas, we drove a pickup truck at the time and a minivan. We collected all of that data over the year. And I'm ashamed to say that our first year, our carbon footprint just for our scope 1 was 21 tons. And that's what you get when you have an oil furnace and a pickup truck and a minivan. But it's pretty typical of most rural people. That's about where they are. So we wanted to see what we could do. So one of the things, and because I'm not an expert in any way, shape, or form, I don't have the advantage of all the education that Patrick has around energy and all that, I knew that I needed to hire somebody to come in and help us understand exactly what we could do in the house and to reduce it. And that since we had a long time frame to play with, we might do this over a number of years. So we hired a company out of London. They came and did the initial assessment, a blower door test, all that, and we scored a whopping 65. So at the time, that was about average for houses at that age. So we were right on average. I didn't feel terribly bad about that. I really appreciated the auditor went all over the house, the attic, in the basement, everywhere. I thought he did an excellent job. We were very happy with the inspection. After the inspection, as Patrick mentioned, he gave us a report, and in the report he gave us 5 suggestions of what we should do or what we could do to reduce both our greenhouse gas. And you have to remember, in 2008, there wasn't many people doing audits. So I thought was really good about, this would reduce your carbon footprint and this is the cost and all that. So he gave us 5 things. And the first one was to replace a furnace that was 10 months old with a ground source heat pump. And at that point, ground source heat pumps were actually more efficient than air source, which I think that's reversed now. But we put in a ground source heat pump. We had enough land around us because we are out in the country. We directional drilled it out into the field, and it worked very well. I was very pleased with it. Before that, because we were measuring, we knew, and the previous owner had told me that we would burn about 3,000 liters of oil a year with the oil furnace. We burned 3,050 liters the first year, and for the full March to March. And a heat pump was ended up being net about $14,000 installed. So, but our heating bill dropped, or at least our gas bill, electricity bill went up $1,200. So we saved about $1,800 a year. And I thought, 20 years, that's a pretty good investment. And then when you think today, if we did the same thing in the last year, we would have been somewhere around $3,500 to $4,000 savings. And I don't want to only talk about money, but I tend to only talk about money. To me, it's one of it. I think you have to be environmentally conscious, but I think you also have to say if things aren't going to pencil, you can't go bankrupt either. So the second thing he recommended, and you'll hear a lot of similarities with what Patrick just talked about, was re-insulating the attic. And we had 6 inches of insulation, which at the time was pretty standard in a 1973 house for the attic. We had to come back in. Well, first thing we did is they had pot lights in 2 different rooms. I hate pot lights. I took them all out, resealed it, and insulated that part. And then we had a company come in and they blew in another 9 or 10 inches of cellulose on top of it, so that we're much better. I know what the cost was. It was about $3,500, but I can't give you what was our rate of return on that one. Third thing they did was, and again, to Patrick's point, check all the caulking and seals around all doors and windows. And the windows actually, for a house that was probably 30 years old, was actually pretty good. And when they did the blower door test and looking at that, I was actually quite pleased with the windows. I did a bit of work around the doors. Total cost of that was right around $100. And it doesn't sound like much, and I can't actually tell you how much it saved us, but I thought for $100 I don't mind if I can reduce the amount of heat that's escaping. Another thing that I thought was really interesting at the time was that he wanted us to caulk around, and if you can imagine, we have a brick fireplace, and where it matches the plaster for the ceiling and along the walls, he said it's leaking air there. And so took a caulking gun and did it all the way around there, got up in the attic and did it from up in the attic. Made a huge difference. And I would have never even have thought of it if the auditor hadn't said, can you see where it's blowing in here? And then the other thing was around all of the outlets on the outside walls of the house, he insisted we put this little foam around each outlet. And total cost of doing all of that was about $50. Well, I don't know how much the foam around the outlets helped us, but I know the sealing with a couple of tubes of caulking was made quite a difference. I noticed that. And the fourth thing, or the last thing he recommended was insulating the basement walls. And so like Patrick, tore everything off, half the house was already insulated, the other half wasn't. Tore everything off the walls, moved it out of the way, put up the studs. We didn't give 2 inches, we only had 1 inch between the stud and the wall. And then put 3.5 inches of foam in, right up to the floor joists and right up to the floor all the way around. And of all the things we did, that's the one that I'm most impressed with, because it's unbelievably how much warmer it is down there than it was, like you go down and work there all the time now. I really like our basement now, but before it was cold and damp, and it made a huge difference. So if I were recommending what would I do first this time, I might start with that. That costs us, not counting labor, that costs us about $4,000. We did the first test in January of 2009. It was about March or April of 2010. They came back and did the retest, and we scored 83. So is that perfect? No, but for a 30-year-old house or whatever, I was actually pretty happy. I figured that good enough. And when I looked at sort of our cost of energy and all that, I figured, well, we can, totally, we spent about right around $22,000. And I think we got that all back in the first 10 years. So the next 10 years, I keep the money in my pocket. I liked the idea that at the time when he did the blower door test in January, I wasn't so sure I liked the idea. But when you saw where the cold air was going or coming in, and that it actually was really helpful. So I wouldn't necessarily tell you need to do it then. I'm just saying I found that really helpful. And then having come back and do a second blower door test, so that in my own mind, I at least say, well, I went from 65 to 83. I think it's helpful just for your own peace of mind. So then I was going to finish just with a couple of quick things. Why do an audit? For me, it was I needed somebody that understood a lot better than I did, and who was independent and unbiased. He could have made any list of things he wanted, but I thought I got a fair, honest, accurate assessment of the house and what we could do. And quite frankly, he gave you kind of a ballpark of it's going to cost you about this much or that much or whatever. And I thought that was really helpful. He compared the work, like the money you're going to spend, to kind of what the value would be at the end. And I think that was helpful as well. And I always appreciate people that from the outside that bring their expertise, and just talking about what did you see in the house and what kind of little tiny things around sealing the hatch that goes. You never see it in our house because it's in the back of a closet to get up into the attic. And frankly, I'd never seen it, done it, anything with it, until he came and pointed out, well, if you actually kind of sealed that off a little bit, it would save it. It was in a closet in a spare bedroom. You never even noticed it. So, from a township perspective, very briefly, we've done every building that has heat in the township. We've done audits on. Same idea. Is there things we can do to save money and reduce our costs, reduce our carbon footprint? And so we have no more oil in the township. All the buildings have moved to natural gas, and we had a few oil ones before. We're now looking at heat pumps. Does that make sense? All the street lights, of course, are LED. We're moving all lighting and that stuff is reduced energy cost. And we're now moving from simply a building audit. We're now zeroing in to do electric audits on all of our buildings. So we know exactly whether the refrigerator in that hall is normal, or the refrigerator in that hall is using too much power or anything. It's not terribly expensive, and in some cases I think it'll pay for itself in a year or two. As I said earlier, and my final comments, as I said earlier, in 2008 when we moved into the house, we did 2008 and 9. We did a measure of all the fossil fuel that we bought, and I'm not counting the fossil fuel that produced the vegetables that we ate or the whatever, just what we direct consumed. So scope 1, and as I said, we were at 21 tons. So we set a goal of just reducing that by 50%. And we thought, well, we could probably do that. So we got rid of the oil furnace. Got rid of the pickup truck. I actually gave it away. Replaced it with a Prius. So we had a Prius and a minivan. We bought the Prius used because I wasn't sure I was going to like it. We paid a little over $12,000 for the Prius. In the money we saved between what it used in gas and what the minivan used in gas over the next 8 or 9 years, we got the car for free, just on gas savings alone. And that was a huge, and I'm a type of person that actually pays attention to this stuff. I know it, I'm a little bit anal maybe, but that's the kind of stuff that I really pay attention to. And when I realized that I actually got that car for nothing, and it was a great car, like I'm really pleased with it, but it didn't cost much. So then we replaced the minivan. I leased an electric car for 3 years, and then after the lease was up, actually bought another electric car, and that's what we use now, a Chevy Bolt. It's costing us about 3 cents a kilometer to drive, and that's purchasing electricity. Great little car, really like it. But our carbon footprint has gone from 21 tons, and after the first couple of years, we got it down to 9 tons, so I was really pleased about that. For the last 4 or 5 years, we've been down to under 2 tons, and in 2022, we're down to 1.1 tons. This year, we're a little higher. And again, that doesn't include external energy, just what we're doing ourselves. But I've never wanted to tell people you should do something unless I've done it myself. And so I think it's one of those things that you try things and you try to explain to people, this is what we're doing, and these are the results. And anybody wants to come and see our hydro bill, come and see our hydro bill. Having said that, the last thing I would say is we built 10 kilowatts solar panel in the microfit program. No comments on that program, but part of it was that it would be part of our energy generation for ourselves. And then about 5 or 6 years ago, we built another 10 kilowatts. So every bit of energy, we don't have anything gas in the house at all, except for the one car, our lawnmower and a chainsaw. Everything else is electric. But we produce enough power now to more than fill all the demands. So electric, like hot water, heat, cooling, everything, we can produce all of our own. And that was sort of my goal. I didn't want to produce power until I made sure I dampened down my demand for it as much as I possibly could. So my recommendation to anybody was get an audit and then start on the conservation. I'm not discouraging people from generation, and certainly as we move forward in the municipal world and as we electrify, we're going to need a lot more energy or generation local. But I would encourage you to start with getting an audit, find out what your problems are, and then work towards how do you conserve, because that's by far the cheapest form of energy consumption you've got. With that, thank you very much. And if there's any questions, Patrick will be glad to answer them.